Hey everyone, welcome to Pilot Math. We're going to make a basic analysis spaces series to help our proofs go a little bit smoother, so that way we don't have to spend time talking about the definitions and axioms of spaces. So for the time being, what we're going to need are what you'd consider maybe basic analysis spaces. Those are going to be topological spaces, metric spaces, Cauchy or complete metric spaces. Those are all kind of one group, and you can kind of see they nest into each other. Topological spaces are a very general notion of closeness. Metric spaces are a generalization of distance, which kind of is part of closeness. And Cauchy spaces just means we're complete, which we'll talk about eventually. We're also going to talk about and need vector spaces, normed vector spaces, Banach spaces, which are just complete normed vector spaces, inner product spaces, and Hilbert spaces. Now, you'll notice that there's a little bit of a relation that's more complicated here. All of those are vector spaces, but normed vector spaces contain inner product spaces because an inner product can induce a norm. And what that means is if you have Banach spaces, some Banach spaces are not from norms, are just from norms, whereas others are not from inner products. So that's where you get all Hilbert spaces are Banach spaces, but Banach spaces are not necessarily Hilbert spaces. Very strange sort of relation, but you can see it depicted in the picture here. It's actually rather straightforward. So this series will get us familiar with these ideas and concepts, and it'll allow me to, when we prove things in various spaces, I can just link to a video on what they are. Anyway, go ahead and like, comment, subscribe, and I'll see you in the next video. Somewhere over here.